Hello dear students, welcome to maths class. Today we are going to take our new lesson, that is the 10th lesson, polynomials. Do you know what is a polynomial? Yes, we have studied about polynomial in the previous classes, 8th and 9th. Okay, in 8th standard, have studied about identities. Do you remember identities? Yes, what are identities? Yes, a plus b whole square. A plus b whole square is equal to a square plus 2ab plus b square. This one is an identity. Okay. Similarly, we have a minus b whole square is equal to a square minus 2ab plus b square. Okay, this is also an identity. And a plus b into a minus b is equal to a square minus b square. All these are called identities. Right? So, this one is an algebraic expression. Right? This a plus b is an algebraic expression. Similarly, this a minus b is also an algebraic expression. Right? And this one is also an algebraic expression. So, this expression into this expression gives a second or third expression. That is, what about degree of this algebraic expression? See, here the powers of the variable exist is 1. See, both a and b. Okay, both are having powers 1. Right? Similarly, in a minus b also, the powers are 1. And if we product first degree polynomials, okay, that is degree means here the highest power is 1. Okay, so if we multiply two first degree polynomials or two first degree algebraic expression, we got a second degree. See, here the power is 2, right? A square, the power is 2. Similarly, b square, the power is 2. So, if we multiply two algebraic expression with the power 1, then we get another algebraic expression with the power 2. Okay, so using this we are going to move our chapter, that is polynomials. Okay, so we know this result, a plus b into a minus b is equal to a square minus b square. So instead of a, here I am going to take x, and instead of b, here I am going to take a. Okay, so x plus a into x minus a. What is this? Yes, x plus a and x minus a. If we multiply, instead of a plus b, here we have x plus a, and instead of a minus b, here we have x minus a. Okay, so if we multiply x minus a and x plus a, we get x square minus a square. Okay, that is, this one is a first degree polynomial. Okay, this one is a first degree polynomial because here the variable's higher power is 1. Which variable? Yes, x and 1, both are in power 1. So, if we multiply two first degree polynomials, we get a second degree polynomial. Okay. Or if we multiply a second degree polynomial and a first degree polynomial. See, if we have a polynomial like this, x square minus a square, then I am going to multiply this with the x plus a. Okay, then what will we get? Yes, we get x into x square, that is equal to x cube. Then x into minus a square, that is equal to a square x. Then x into a into x square is equal to plus ax square minus a square into a is equal to a cube. Okay, so here the power is 3. So if we multiply two first degree polynomials, we get a second degree polynomial. Similarly, if we multiply a second degree polynomial and a first degree polynomial, we get a third degree polynomial. Okay, so if we multiply two first degree polynomials, we get a second degree polynomial. If we multiply a second degree polynomial and a first degree polynomial, we get a third degree polynomial. Okay, so here we have x plus a and x minus a. X plus a into x minus a is equal to x square minus a square. That is, we multiplied x plus a and x minus a together. Then we have x square minus a square. That means for the polynomial x square minus a square, these two are called the factors. Okay, so which are the factors of the polynomial x square minus a square? Yes, the factors of the polynomial x square minus a square is x plus a and x minus a. Okay, that is these two into these two polynomial gives this polynomial. Then these two are called the factors of this polynomial, right? That is, see, 2 into 3 is equal to 6. Okay, we can call this 2 and 3 as the factors of 6. Okay, 2 and 3 are the factors of 6. Similarly, x plus a into x minus a is equal to x square minus a square. And in the last class, that is in ninth class, we have studied about polynomials. And in that class, we know how to represent a polynomial. Yes, how do we represent a polynomial? Polynomial in the variable x, we note like this, p of x, right? P of x. And we can take another variable like this, that is q of x or r of x. All these are representation of polynomials. Okay. So here we have, that is x minus x plus a into x minus a is equal to x square minus a square. Okay, that is a first degree polynomial into another first degree polynomial gives a second degree polynomial. Okay, instead of this, I am just taking all this as some polynomials. Okay, that is, I am going to take this x square minus a square as p of x. Okay, this one is p of x, and suppose this is p of x, that is a polynomial in x. This is a polynomial in s, a second degree polynomial in x. Okay, so here I am going to, generally I am going to take this x square minus a square as p of x. Okay, and this x plus a as, yes, this one is a first degree polynomial q of x, and this x minus a is a first degree polynomial, that is r of x. See, this polynomial p of x is actually the product of two first degree polynomials q of x and r of x, right? So we can say that this q of x and this r of x are, yes, q of x and r of x are factors of p of x. Okay, these two are called factors of p of x. Okay, so we can find out the factors of any polynomial. Okay, in p of x, okay, this is p of x, right? What is p of 1? Yes, in the place of x, if we substitute the value of x instead of 1, okay, we get, what is that? Yes, we get p of 1, right? That is, what is that? Yes, p of 1 is equal to, instead of x, we just substitute the value. That is equal to 1 square minus a square. Okay, what is 1 square minus a square? 1 minus a square. Right? P of 1 is equal to 1 minus a square. And see here children, here we have x plus a and x minus a. Right? P of 1 is equal to 1 square minus a square, that is equal to 1 minus a square. Then what is P of 2? Yes, in the place of x, we just substitute 2. Okay, that is equal to 2 square minus a square. Okay, do you remember all these things? So, we can write a second degree polynomial as the product of two first degree polynomials, or we can write a polynomial p of x as the product of two other polynomials q of x and r of x. Then this q of x and r of x are called the factors of p of x. Okay? Can you tell the factors of the polynomial x square minus 1? Okay, x square minus 1. See, this is actually in the form of, yes, x square minus a square, right? X square minus a square, we know that 1 is the square of 1 itself, right? 1 is the square of 1 itself. So, this is actually in the form, yes, x square minus 1 square. We know that, yes, the factors of x square minus a square is x plus a and x minus a. Similarly, what are the factors of x square minus 1 square? Yes, factors of x square minus 1. See, here we have x. Okay, then plus a. Here instead of a, what we have? 1. So, we have x plus 1 into x minus 1. So, we can say that the factors of x square minus 1 square are x plus 1 and x minus 1. Okay, then what about x square minus 4? What are the factors of x square minus 4? Yes, the factors of x square minus 4. We can write this x 4 as, yes, 4 is also a perfect square, right? That is equal to x square minus 2 square, right? X square minus 2 square. Then, now this is in the form of x square minus a square. Then the factors are x plus a and x minus a. So, which are the factors? Yes, x plus 2 comma x minus 2 are the factors. Okay, x plus 2 and x minus 2 are the factors. Can you tell me what are the factors of x square minus 2? Is this 2 a perfect square? No. But we know its square root. What is its square root? Yes, it is an irrational number, right? Which is, yes, we can write this 2 as the square of root 2, right? Root 2 square is 2. So, we can write this x square minus 2 as x square minus root 2 the whole square. So, which is equal to x square minus root 2 the whole square. So, we can write this as x plus root 2 into x minus root 2. So, we can say that these two are the factors of x plus root 2 and x minus root 2 are the factors of x square minus 2. Okay, similarly, we can find out, yes, the factors of every second degree polynomials, or we can write every second degree polynomial as a product of two first degree polynomials. Okay, so if, yes, here we have a polynomial x square minus 1. Okay, I am going to take this polynomial as p of x. Okay, p of x is equal to x square minus 1. Then, which are the factors of, yes, which are the factors of p of x? Yes, we know that for the polynomial x square minus 1, the factors are x plus 1 and x minus 1, right? X plus 1 and x minus 1 are the factors of the polynomial x square minus 1. Then, see, here we have x minus 1 is a factor, right? X minus 1 is a factor. Then, what about p of 1? Yes, p of 1 is equal to, if x minus 1 is a factor, here we have x minus 1 is a factor. So, we have p of 1. Just substitute, yes, 1 instead of this x in this polynomial. That is what we call p of 1, right? That is 1 square minus 1. So, that is equal to 0. Okay, so here we have, yes, p of x is equal to x square minus 1, and we know that x minus 1 is a factor. Then we have p of 1 is equal to 0. Okay, one more number. What about p of negative 1? P of negative 1, here we have x plus 1 as a factor. Then I am just taking this as p of negative 1. What is p of negative 1? That is equal to negative 1 whole square. Instead of x, just substitute negative 1. So, negative 1 whole square minus 1. What is negative 1 whole square? 1. 1 minus 1 is equal to 0. Okay. So, for these two values, that is for 1 and negative 1, we have p of 1 is equal to 0 and p of negative 1 is equal to 0. Then what about p of 2? P of 2. Yes, p of 2 means instead of x, just substitute 2 there. That is 2 square minus 1. What is 2 square? 2 square is equal to 4. 4 minus 1 is equal to 3. See, this 2. P of 2 is not equal to 0. So what does it mean? Yes, we can say that yes, P of 2 is not equal to 0. Therefore, we can say that x minus 2 is not a factor. Okay, the two factors of this polynomial is x plus 1 and x minus 1. Okay, so we have P of 1 is equal to 0 and P of negative 1 is equal to 0. Okay, 2x plus 1 and x minus 1 are factors. Then only we have P of 1 is equal to 0 and P of negative 1 is equal to 0. Okay, then all other numbers are not equal to 0. Okay, P of 2 is not equal to 0. P of 3 is equal to not equal to 0. P of 5 not equal to 0. Okay, for any number, P of that number is not equal to 0. If it is a factor only, P of that number is equal to 0. Okay, so in general, we can say that yes, if x minus a is a factor of the polynomial x minus a is a factor of the polynomial p of x, then p of a is equal to 0. Okay, x minus a is a factor of the polynomial p of x, then p of a is equal to 0. See, here we have x minus 1 is equal to, x minus 1 is a factor, right? X minus 1 is a factor of this polynomial p of x. Then we have p of 1 is equal to 0. Okay, that is, see, here we write this x minus 1. Okay, then what about x plus 1? Yes, we can write this x plus 1 as, yes, x minus 1. Right? That is x minus 1. So, here we have, yes, x minus 1 is a factor. Similarly, see, x minus 1. So, p of negative 1 is also equal to 0. So, x minus a is a factor, then p of a is equal to 0. For this polynomial x minus a is a factor of the polynomial p of x, then p of a is equal to 0. So, this is an easy way to check whether a polynomial is a factor of this polynomial or the given polynomial. Okay, x minus a number. Okay, that is, if we need to check x minus 2 is a factor, we need to check p of 2 is equal to 0. If p of 2 is equal to 0, then we can say that x minus 2 is a factor. Okay, if we need to check x plus 2 is a factor of a polynomial, then p of negative 2 is equal to 0. Okay, if x plus 3 is a factor, then p of negative 3 is equal to 0. If x minus 3 is a factor, then p of 3 is equal to 0. Okay, so which number is subtracted here? That number, p of that number is equal to 0. That is the condition to check the, yes, that is a factor, whether it is a factor or not. So in general, yes, we can say that if x minus a is a factor of p of x, then p of a is equal to 0. Okay, and one more thing, we can say that a is the solution of p of x. Okay, a is the solution of p of x. What does it mean? Yes, instead of this x, if we give a, we get 0. Okay, then we can say that x minus a is a factor. Okay, see children, this is the explanation, that is, if x minus 1 is a factor of the polynomial x square minus 1 square, then we have p of 1 is equal to 0. Okay, this is actually the, yes, an example of this sentence. So, in the next class, we will discuss how to find the factors of some other polynomials. So, this is only an introduction of this chapter. Study well, children. Thank you.